All right, so what we're going to do today is I'm going to make several videos and post them all. This is the optimization for the MyMathLab Day 2. So Day 1, I already did those videos. Day 2 is just a series of questions. I believe there's 7 questions, and they're just different setups of looking for the same thing. We're looking for maximum or we're looking for minimum. So the first one, the question is, find dimensions with an area of 120 feet, 21 feet squared that has a minimum perimeter. So this is a little bit different. Before on Day 1, we did maximum area. Now we're talking about minimum perimeter. So when we get to finding the domain, you're going to find that it's a little bit different. The answer is a little bit different, and the reason is because we're looking for minimum perimeter, and our constraint is the area. So let's just go through the process. So remember, the first thing we want to do is we want to find our objective. So the objective is minimum perimeter. So we're looking for a perimeter function. So perimeter, remember, of any rectangle. I didn't write rectangle. Find dimensions of the rectangle, that's what it's looking for, is 2 length plus 2 width. That's our objective. The constraint is our area. Because we only have a limited amount of area, that's what's going to keep us from being able to get whatever whatever values we want. So our constraint is area equals 121 feet squared. Now, area is found by length times width. Right? So now we're going to set our constraint to one variable. We're going to solve for one variable. We can solve for whatever we want. In this case, I wanted to solve for width. Okay? So now what we've done before is we've said, okay, now we need to set the domain. The constraint is set for one variable. And remember, we're going to save this because we're going to have to use it again. And now what we want to do is we want to find out what the domain restrictions are. Well, in the past, what we've done is we've set our constraint to greater than or equal to 0. So if I just go through the process, I'm going to multiply both sides times L, and we end up with 121 is greater than or equal to 0, because 0 times L is 0. Well, we have a problem, right? We have a problem. This is a true statement, so we're good here. The reason why the constraints don't work out quite right is because when we're dealing with area, if you remember, area of a rectangle can be a very small width and a very large length, or it can be a very long width and a very small length, or it can be any combination of those two. So there's no real set amount, because I could have 1 times 121. That gives me 121 squared. I can have 3 times 40, or I'll do it this way. 3 times 40.3333, and it keeps on going. So there's no real set way to be able to find what our length and width is in terms of a domain restriction. So with this case, when we're looking for minimum perimeter, we really don't have a domain restriction. All we know is that our width has to be less than or equal to 121. It's our highest number. It's got to be somewhere in between 0 and 121, and so we can just leave it at that. All right, so we have our objective. Our objective is our minimum perimeter. We have our constraint. We've set our constraint to one variable, and now we're going to plug our constraint into our objective. So our perimeter equals 2 length. Our width is 121 over L. So now we have our perimeter in terms of L. So we have 2L plus 242 divided by L. Okay, so now I'm going to rewrite this so I can find the derivative. 2L plus 242 L to the negative 1. So remember, our L is on the bottom. We push it to the top. It becomes a negative exponent. And now I can find my derivative. Bring this to the front. Bring this to the front. So it becomes a negative 242L, and we're subtracting 1, so we get to the negative 2. So now we can set this to 0. So remember, our L to the negative 2 is actually 2 minus 242 over L squared. You can do it this way also, so you can solve it either way. So I'm going to keep it as a negative, and then I'll show you how to solve with the negative. And then I'll do it as over L squared. Okay, so here we go. We're going to subtract 2 from both sides. So negative 242L to the negative 2 equals negative 2. I'm going to divide both sides by negative 242. So I get L to the negative 2. If I reduce this, this is 1 over 121. Okay, just checking, making sure my numbers are right. All right, so now I'm trying to get rid of this negative 2. So what I'm going to do is I'm going to raise this to a negative 1/2. All I'm doing is flipping this over, because the idea is whatever I multiply by, when I multiply, I want this to become L to the first power. I want L by itself. So when I multiply by the reciprocal, I'm going to get 1. Well, I have to do the same thing here. I have to raise the other side to negative 1/2. So I have L equals, because negative 1/2 times negative 2 is 1. And then remember, a fractional exponent, if it's negative, it says flip it over. And then the fractional exponent is a root. So this is actually this flipped and then the square root of that. So it looks like this. When I flip this over, I get 121 over 1, which is just 121. So 121 to the 1/2 power is the same as the square root of 121, which is 11. So my length, this was my length. My length equals 11. So to find my width, it's 121 over 11, which is also 11. So the dimensions are 11 by 11. Okay? Now, let me go through this one more time, and I just have to go from here, and I can show it to you another way if you don't want to deal with a fractional exponent. So now I'm going to solve this, rewriting this. So this L to the negative 2 drops down. It becomes L squared on the bottom equals 0. So now I can do the same thing. I'm going to subtract both sides by 2. So I get negative 242 over L squared equals negative 2. Okay. And now, because this is a proportion, right, I can just put this over 1. I can actually do my cross multiplying. So L squared times negative 2 is negative 2L squared. Negative 242 times 1 is a negative 242. And now I have a straight equation. I can divide both sides by negative 2, and I get L squared equals 121. Square root both sides. I'm going to move up here. So I get L equals the square root of 121 is plus or minus 11, because anytime you square root, you're going to do a plus or minus. But because we're talking distances, the negative is extraneous. So again, your length is 11. Plug it into here. 121 divided by 11 gives you 11. So your dimensions are 11 by 11. When I multiply these two, I get 121. So I know I've done it correctly.